So now that we know what a force is, it's time to get into some specifics. And Isaac Newton is the guy who figured out the specifics on how forces behave. So we're going to be talking about him a lot. And we're going to be talking about force diagrams, which is how you draw forces. If you're the artistic type and you like sketching stuff out, you're going to really enjoy this section. It's going to be pretty easy for you. So Newton came up with three laws that do a great job of describing the vast majority of physics that we know, or at least the stuff that we knew until about 100 years ago. And we're going to go through them one at a time. So his first law says basically that anything that's sitting or anything that's moving is going to keep doing that. Maybe you've seen videos of spaceships and whatnot in movies, and if it's moving, it doesn't have to have its thrusters on to keep moving. If something's in space, then it just keeps on traveling. Now, there's the illusion that this isn't true because on Earth, you can't really get rid of the force of friction. So if you have something sliding down the road, it's eventually going to come to a stop. But that's not because Newton's first law is wrong. That's because there's another force. There's friction involved. But if we can get rid of all of the forces, the object is simply going to keep doing what it's doing. Now, the second part of Newton's first law says if you have an unbalanced force on it, then the object will accelerate. And the definition of accelerating is to not keep sitting or to not keep moving, but to change your velocity. So basically, if the forces are balanced, acceleration equals zero, the object keeps going at a constant velocity. If the forces are not balanced, then there's going to be an acceleration that's caused by that. So without further ado, I give you the 3 steps for drawing a force diagram. Step 1, draw the force of gravity because you are not getting rid of it. Pretty much every single problem you see in this class, if you're drawing a force diagram, you're not going to get rid of gravity. It's going to be there. So just draw it. And if you don't know which way gravity goes, then I feel sorry for you. Step 2, draw a little box around the object so you can focus in on it and see exactly what's touching it. Because with the exception of gravity, all of the other forces I've been talking about require contact with the object. So you have to look closely at what's actually touching the object to see what the forces are that's affecting it. Step 3 is to draw the forces you discovered in step 2, so basically all the forces besides gravity, on your force diagram. And also make a note if the object is accelerating or not, because if it's not accelerating, then your forces have to be balanced. And you'll see that in some examples coming up. Okay, so let's go through some examples. For the first one, we've got a block that's just chilling on a table. It's just sitting there, and we want to know what the forces are on it. So we're going to draw a diagram. To make the drawing a little simpler to see, rather than drawing the block itself, we're actually just going to draw a dot to represent it. It just makes things a little bit simpler. And step 1, the first force on it is going to be the force of gravity. So you draw a downward arrow, and we just write a FG right beside it. Step 2 says we need to draw a little box around this thing so we can easily see where the contact is taking place. So I'm just going to get a little dotted box. You don't have to do this step, but I've heard that it helps some students to see it. But if you really focus in on this, there's one point of contact, and that's between the block and the table. So that means there's one additional force. And that force is actually the normal force in this case, and the normal force points up. It's basically the table saying, look, you don't get to go through me. If you're going to try to push on me, I'm going to push right back on you. I'm not going to let you just sink through. Now, if you had a weak table, it would go through, but we'll say this is a strong table. So it exerts an upward normal force. And while I didn't draw this perfectly, these two forces should be in balance because it says that the block simply sits on the table. It's not accelerating. For the next one, we have a block that's simply being held up by a rope, and again, it isn't moving. So first step, we're going to draw our force of gravity on the block. Next, we're going to draw a little box around it just so we can kind of focus in on exactly what's touching the block, because you don't want to invent forces that aren't there. So if you look closely at it, there's only one thing touching the block, and that's the rope. And the rope is a force of tension, and it has to be pulling up on it. So we get an upward force of tension, and we end up with an answer that's very similar to the last one. By the way, don't worry too much about the size of these forces yet. I'm just trying to give you the general idea. Later on, we're going to actually calculate the amounts of these forces.